In this video I'll be showing you, does UF really matters on capacitor or not? I know some of you might have been thinking about it, especially the beginners. You can see this one is 400 volts 8.2 UF, why this one is sorry, let me show you where so you can see. Pity my camera. And don't forget, I'm trying to get a good camera. In case you feel like supporting me, feel free to do that. I have a link in the description that says show me love. You can feel free to do that. Alright, so this is 50 volt 470 UF, why this one is 400 volt 8.2 UF. You can see it. So, and I have another one here which is 400 volt 2.2 UF. So let's use this three as a case study and check it out. All you need is multimeter. You don't need any form of power supply. So very simple. Take your multimeter, put it to continuity mode. Let me adjust this camera, please. Alright, put it to continuity mode to check it. It's sounding. We are good to go. So let's start with the first one. Let's first do the experiment between the 400 volt and the 50 volt. You know what we are powering, this this meter use just 9 volts, so that is also the two capacitor can bear it. Then this one is 470 UF, while this one is 8.2 UF. So very simple. So since we are in the continuity mode, your negative probe, you know this ash area on your capacitor is the negative side of it, so take the negative there. You know, we are trying to do the two experiments. Take the negative here and the positive here. You can see it, your capacitor will change. Once it changes to 1, then it is fully charged. Right now, I believe you saw the weight. Let me discharge so that you see what I'm saying. Let me discharge to 0 back. Please pay attention. If I touch it, you see the way it's reading. When it gets to 1, it will stop. So that means it is fully charged. Good. Then take it to voltage. Since this is 9 volts multimeter, then if I use 20 volts, I'm okay. Now take your meter. What we want to do is we'll read it. We'll be seeing the voltage. We'll be seeing the rate at which it drops. Please pay very good attention here. The positive is still touching this. Then my negative touch this. Be looking at the meter. Let me restart. You see, sorry. Maybe I hold this with one hand. Then the other. Let's touch it now. Oh, my hand has discharged it. Let me come back again. Let me discharge all through. And let's charge it up very fast. It's because I don't have a tear down tools, that's why. Let me put this capacitor where you can see it clearly. Alright, so my positive is here, then my negative is here. We are trying to charge it up, it's full. Then move to 20 volts. Let me just support this. Now look at the meter. You see it's currently you see the way it's dropping. Very slow. This is 2.51, 2.50, 2.49. You see the way it's dropping very slow. Be looking at that meter. You can see this one is a 470 UF. You can see 2.47, 2.47. Let's see, to drop to 6. You see, if we are counting, I'm very sure the second is much. The time it's taking to drop is very much. Now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's almost like 10 seconds interval for this one to discharge, because it is 50 volts. See, right now we are powering them with 9 volts, so we don't have issue. We are just trying to compare the UF value. So this, for this 470 UF, at least for it to lose just 0.01, it's taking like 10 seconds. So let's now look at another one which is 8.2 UF. You know, we are trying to look at, does the UF really matter? Now this is a negative area. The same way, first thing, discharge it. Remember, in case you are dealing with a high capacitor, this is not the right way to discharge. So in case you want to do it this way, protect your eye anyway, and touch it and be fast. Not that you touch it this way, you know, especially all this 100 volt capacitor and the rest. And when it has fully stopped, then just touch it with the wire very fast and it will discharge. Alright, so now let's move to continuity now. Remember the way we do it, negative to negative. This is my negative area. Let me bend this so my probe can easily rest on it. Now let's go. It's charged already. Let's see, it's in continuity mode. It's fully charged. It's because it's a very high volt, so this 9 volt will not power it very far. It will just be, very minor for it, so it will not show the full reading, but it's charged now already. So let's now go to 20 volt for our DC reading. Then we'll put the positive here, put the negative. You can see the rate at discharge, which it is discharging. So you can see it very, very fast. So this to tell you that the reason is because the UF is very, very low. That one was 470 UF, while this one is 8.2 UF. So definitely the rate at which they will discharge is very, very different. So that is to tell you that so no, the difference between these two is just that in the circuit, depending on what you are using it for. So if what you are using it for require more power stability, then you need higher UF. You understand? Apart from the voltage, you still need higher UF. But for this one, this 400 volt is usually common in power stage of appliances, because what we need is just the power to flow there, and in case there is no electricity, then it should discharge very fast. But in this case, let's say in your circuit now, in the preamp and the rest, you need, in case there is any power drop and the rest, you don't want your circuit to fail, so you need something that can still save the energy for some time. So that is why you need higher UF. So depending on the use case, that will determine the UF you need. I believe you fully understand with these two comparisons I've done. So if you see a capacitor of like 10,000 UF, 1,000 UF, this one will store and they will discharge very slow compared to this one. You understand? So that's just the way to work. So based on your circuit usage, you should be able to decide what you really need for it, aside the voltage. So it's not just all about the voltage I need this station. No, the UF too really matter. If this video helped you to this extent, like, share and subscribe, and don't forget I have a PDF. You can check it in the description. It's perfect for beginners who are just starting an amplifier building. See you in my next video. Peace.